This video covers a number of tests that one might choose for an ignition system. You will need a digital voltometer for resistance checks. Jumper wires are recommended for these tests. However, T-pins with a light coating of dielectric grease would provide a useful workaround. You will need a high impedance incandescent or LED test lamp. Additionally, an oscilloscope will be useful for primary pattern diagnosis. One could choose many of these tests for virtually any ignition system. On this system, the grounds for the coil primary windings are turned on and off directly by the PCM. We start with a visual inspection of the ignition system components, the coils, connectors, wiring, an inspection of any control device like the PCM or ignition control module. Next, we'll remove the coil for further testing, releasing the connector position assurance clip, removing the connector, and we'll unbolt the coil at this point. Coil removal next, with a visual inspection for blisters, burning, carbon tracking. We'll check to see that the primary pins are in alignment, and we'll look at the secondary output end. Next, we can reconnect the coil. We'll install a spark tester and verify that the coil is able to drive a spark tester at the specified output voltage. In this case, we're going to set the spark tester up for 30 kV and ground it to the engine. We'll crank the engine and verify that the coil has the output necessary to fire the spark tester. In this case, it did successfully fire the spark tester, confirming that the coil, its feed, and its control are all operating adequately. We could now check or replace a spark plug, check compression, fueling, or any airflow issues. If the coil didn't fire the spark plug, we could test coil primary and secondary resistance, coil power feed, and coil ground control. Coil primary and secondary resistance checks can be useful. Here, we're connecting adapters to allow us to conveniently connect to the primary terminals. For the primary check, we'll use a digital multimeter set to the lowest resistance scale available. We will test the resistance across the primary terminals and compare it to specifications. In this case, the resistance is 0.55 ohm. Next, we'll measure coil secondary resistance using a multimeter set to a high resistance scale, in this case 20 k ohms. We'll probe from one primary terminal to the secondary output terminal and compare the reading to specifications. In this case, the resistance is 11,500 ohms. Installation of jumper wires will allow us to conveniently test the coil primary, feed, and ground. Alternatively, this is where T-pins could be used. Now the coil is reinstalled for more testing. This diagram represents our ignition system. In blue, we see the primary circuit. In red, we see the secondary circuit. The primary circuit starts with the battery feed. It includes the coil primary winding and any ignition control device, in this case, the PCM itself. The secondary, illustrated in red, includes the coil secondary winding, any spark plug lead, and the spark plug itself. This test uses a test lamp or voltmeter to prove the coil feed. By connecting the test lamp between battery negative and the coil feed and cranking or running the engine, we can verify the feed. For this test, we have the test lamp connected between battery positive and the coil primary negative terminal, and flashing of the lamp proves the PCM control of the coil. An oscilloscope connected between battery negative and coil primary negative shows us battery voltage, confirming the feed to the coil and basic continuity through the primary. It shows a clean downturn, confirming dwell. We can see dwell time by turning on the cursors, and we see the dwell time here is 2.67 milliseconds, a normal value. And we can even get an insight into the secondary. Here we see the spark plug burn time. By turning on the cursors, we see that it's 2.16 milliseconds, again a normal value.